What's up, you guys? I'm Uzi. This is my series on computer networking basics. It's episode 3, and today we're going over subnetting. Subnetting is just taking one big network and dividing it into two or more networks called subnets. And to really understand subnetting and how it works, you need to understand these three key concepts. The network ID is the portion of the IP address that identifies the network. The host ID is the part of the IP address that identifies a specific device on the network. And the subnet mask. This determines which part of the IP address is for the host and which is for the network. You could kind of think of it like a hotel. The network ID is the address on the outside of the building. It tells you what building you're at or what network you're on. The host ID could be a room number, a specific room number on a certain floor, and on each floor, there's several rooms, several host IDs. And so subnetting is basically the process of adding floors to that building. Each floor is a new subnet mask. Now this is a subnetting table. This is a very useful resource. This specific one goes from 24 to 32, but they go all the way from 32 to 0. My recommendation is to Google one, print it out, put it on your desk so you always have it in front of you. It'll really help you get a grip of this concept when you're going over problems. Let's use this top row as an example. What does this mean? /24. If you remember from the last video, I explained every IP address has 32 bits. And for IP addresses, these bits are 8-digit combinations of zeros and ones that represent an integer, the integer between these periods. So each integer between these periods is worth 8 bits. So what you have here is 24 host bits, 8 plus 8 plus 8. That's 24. These 24 bits represent the network. So that's why there's a /24 representing the network bits. That means you have 8 bits for the host, which means the host can be anywhere from 0 to 255 essentially. But then notice right here in the usable host column, it only says 254. That's because in every subnet you have to factor in the network address and the broadcast address. The network address is the first address within that subnet, and the broadcast address is the last address. So for this example here of a subnet mask 255.255.255.0, the network address is 255.255.255.0, the first usable host, and the broadcast address is 255.255.255.255, the last available host. So you really only have 254 usable hosts. And if, for example, that's confusing you, say you look at 25 and you say, oh, okay, that has 25 network bits, so there must be 7 bits for the host, but then you look at 128, and then you think because that's half of 256, I only have 4 bits. No, you have 7 bits. I'm going to show you visually how that works. I want you to take a look at just the last octet. Those are the numbers, and these are the numbers in binary. Remember, a computer at its core reads things in zeros and ones. So when it reads these IP addresses, it reads the network bits as ones and the host bits as zeros. And that is how you get 7 bits for 25, 6 bits for 26, and so on. It's all about the computer reading ones as network bits and zeros as host bits. So that was kind of a visual representation of what the host and network bits look like to the computer. But the easiest way to calculate the host bits is to just subtract whatever number you have in the subnet, 24, 25, 26, just subtract it from 32, and that's how you get the host bits. And this is an equation for when you don't have this table in front of you and you want to find the usable hosts. The equation is 2n minus 2 equals usable hosts, where n is the number of host bits. So now let's say you want to find the usable host for a, let's say, /27 subnet mask. All you do is take 32 minus 27, which is 5, and then take 2 to the 5th power, which is 32, and subtract 2 and you get 30. And what is it? 30. Let's say you wanted to find the usable hosts for a /23. /23 isn't on this table, but you take 32 minus 23, you get 9. 2 to the power 9 is 512, minus 2 is 10, so you get 510 host bits. You can Google that for your own closure, but I'm pretty sure that's right. This right here is another important table you should probably print out and have in front of you for when you go over subnetting problems. This is the IP addressing table. IP addresses are divided into certain classes. For now, I'll just focus on A, B, and C. So not every subnet mask is going to have 24 network bits and 8 host bits like we just went over. Some of them, like Class A, are only going to have 8 network bits. Class B's will have 16 network bits. And a lot of times when you get subnetting problems, you're going to have to correlate the IP address to the correct class first. So this is an important takeaway. So now I can put these tables together and I can show you how to find the number of subnets in an IP address. One thing I haven't really touched on so far in this video is this column in the subnetting table, the number of subnets. How do you get the number of subnets? So for starters, whenever you get a subnetting question, the first thing you want to do is identify the network address. Let's take this random IP for an example. 198.56.102 109.244/26. And just a reminder, I'm not sure if I touched this. This /26, all it is short form for this number right here. This /26 is being read as this full IP address. And that goes for a /27, it would be this one. A /28, it would be this one. This is a short form for this address. So going back to this example, we have this IP address and we need to figure out what network class it's in. So we go to the IP addressing table and we just look at the first three numbers. The first three numbers are all you need to look at. We see we have 198. 198 is in this class. It's between 192 and 223. So this is a class C IP address. And you can see for a class C IP address, the default subnet mask is 255.255.255.0. And if we look here on the subnetting table, we see that 255.255.255.0 is a /24 subnet mask. So to get the subnets for this IP address, we take the default subnet mask for the class that we're in, and we figure out how many bits we need to borrow for our address. Our address is 26. So we'll need to borrow 2 bits from 24 to 26. This is where we get borrowed bits. And to calculate the subnets, you take 2 to the power of borrowed bits. So in this case, it would be 2 to the second, which is 4. So for this IP address, it has 4 subnets. Moreover, if you wanted to count the usable hosts, you would take 32, like we went over earlier. You'd subtract 26, that equals 6. You would take 2 to the power of 6 and subtract 2, and then you'd get the number of usable hosts. So to end today's video, we're going to go through some review questions. First question is to find the number of usable hosts in this IP address. You see the subnet mask 255.255.255.240. We see that it correlates to a /28, meaning 28 network bits. 32 minus 28, and we get 4. We take 2 to the 4th power and subtract 2. And remember, we're subtracting 2 because we don't want to include the network address and the broadcast address. We're talking about usable hosts. So 2 to the 4th minus 2, you get 14, and that's our answer. Next question, you want to find the number of subnets in this IP address. 150.0.0.0, subnet mask 255.255.255.0. For questions when you want to find the number of subnets, remember you want to look at the class first. What class is this IP address in? Looking at our IP addressing table, we can see that 150 is a class B. And a class B has 16 network bits. Now, if we had enough space here for the entire subnetting table, you would see that a /16 would be 255.255.0.0. But the way I got /16 was just from looking at this. The default subnet mask is 255.255.0.0. Now, if you remember, the network bits and host bits are read as zeros and ones. So 255 in binary is 8 ones. 0 in binary is 8 zeros. So knowing that, you can know that this is going to have 16 network bits and 16 host bits. Furthermore, we can see 255.255.255.0 is a /24. So remember, for finding the subnets, our equation is 2 to the power of borrowed bits. To get to 24 from 16, we're going to need 8 bits. So you take 24 minus 16, so we get 8 bits, and then we take 2 to the power of 8, which equals 256 subnets. And our third and final question, enter the valid host range for the network that the IP address 192.168.197.232, subnet mask 255.255.255.128 is a part of. And at first, these questions might seem tricky, but after you do a lot of them, they become very easy. What I like to do is take 256 and subtract it by whatever number is in the 4th octet of the subnet. In this case, it's 128. So I take 256 minus 128 and I get 128. From this, I know that each range will go from 0 to 127. And why 127? Because 0.0 is also an IP address. So we have to include that one as well. So the 0.0 address plus the 0.1, 2, 3, all the way to 127, that will all make 128. So for example, our question, this IP address, the first range of this address is going to be 192.168.197.0, and it's going to end at 192.168.197.127. The second range will be from 192.168.197.128 all the way to 0.255, because remember, IPs don't go higher than 255. But you also have to remember the network address is the first address and the broadcast address is the last address. So for example, in this range, 0.0 is the network address, and this 0.127 is the broadcast address. And for our question, we want to find out where 0.232 lies. Well, it lies between this. It lies between 128 and 255. But like I said, you cannot count 128 and you cannot count 255 as part of the answer, because the valid host range does not include the network address and the broadcast address. So this is your answer. This range is the valid host range. And if a question was to ever ask you what is the network address or what is the broadcast address, and it would give you an IP address, you would go through the same method of thinking, and that's how you would get your answer for the network or the broadcast. And that's going to end today's video. Subnetting can be very complicated at first. All it takes is practice. It'll become very easy. All right, guys, thank you for watching. I'll see you in the next one.